Okay, this section, we're back to graphing. There's just a few of them, and then the rest are solving by substitution elimination. So the graphing systems of equations, what you're going to see in this section is either they wind up being the same line or that they wind up being parallel to each other. And this is going to lead into one of the other sections that we're doing, where you might graph, you might substitute, or you might do elimination to answer whether or not it has many solutions, one solutions, or no solutions at all. Okay, so it's just practicing the lines, what they have in common and what they don't have in common. Okay, so starting on the very first one, we're just graphing the system of equations, which you guys have already been exposed to. So you can do the zero thing on this first one for the standard equation, or you can solve to get y by itself. Okay, so if I were to solve to get y by itself for this equation, okay, I would move the x to the other side, right, because that only has one step for us, so it changes from a positive to a negative, and then just shift that over. Okay, so if I go to graph it, I'm going to graph this part first. So at a negative 4 on the y-axis, I'm going to put a dot. So 1, 2, 3, 4. Okay, then from there, here is my rise over run. So it's a negative 1 over 1 or 1 over negative 1. Okay, so I would, from my negative 4, go down 1 and then over 1, or I could have gone up 1 and to the left 1. Okay, and then we would connect them. So if we didn't want to use that method, remember, you can use the plugging in of 0. So if I put in 0 for x, okay, and then solve for y, then my y would be a negative 4. And then the other thing, if I plugged in 0 for my y, then my x is a negative 4. So if I were to graph those, 0, negative 4 was that first stop that I did, okay? And then the other one would be coming over 1, 2, 3, 4. This would be your line right here, okay? So we're going down this way, okay, which would get you the same line, okay? So what we're looking for now is to graph this one. So to get the y by itself, I would divide by negative 3, divide by negative 3, divide by negative 3. Okay, so then that would give me y is equal to a negative x again, right? Because 3 divided by negative 3 is a negative 1. And then a negative 9 divided by negative 3 would be a positive 3. Okay, so then graphing it, so I graph at a positive 3 first, so 1, 2, 3. Okay, and then from there, I'm going down 1 over 1, right? Or up 1 over 1. Okay, so then graphing those again, if I could draw straight line. Okay, so looking at this, our drawing should look like those two lines are parallel. Also, what we learned in the last section is that lines can be written differently, but as long as the slopes are the same, right? The slope in this first one is a negative 1, and the slope in this one is a negative 1. So that means that these two lines are parallel to each other, even though they're graphed in different areas, okay? So for this one, when they're parallel like this, if they were to ask you how many solutions there are, like if there's one or a lot or many, this would be a no solution, okay? And the reason why it's a no solution is because those two equations never cross each other, okay? They're parallel to each other. So in order for them to cross each other, that would give you one solution, or if they wind up being on the same line, like the two lines are the same, then it'd be many solutions because anything that falls on that line would work. Okay, but this one would be a no solution. Okay, next one. Okay, graphing. So solving for y, I'm going to move the x over and make it a negative x plus 1, divide by negative 1, divide by negative 1, divide by negative 1. Okay, so now I've got just x, right? Because negative over negative is a positive, and then this will just do a negative 1. Okay, so graphing that at a negative 1. And then my slope is up 1 over 1. So up 1 over 1. Okay, and then we'll connect those. Okay, and then my next one, I'm just going to divide by 4. divide by 4, divide by 4. So that gives me 1, just like this one. Okay, and then a negative 16 over a negative 4, okay, is going to give me a negative. Okay, so again, we're going to know that these two lines are going to be parallel because they're the same, right? These two are going to be the same, other than they're just in different locations. Okay, so I'm going down 4, so 1, 2, 3, 4, and then up 1 over 1, or down 1 and to left 1, but still, these guys are going to be parallel. Okay, now again, in this section, they might go back and forth between you like looking at a graph or asking you how many solutions to this equation. So you would also write no solution on this one, okay? But make sure you're graphing when they ask you to graph. Okay, last one on this one. Okay, so I'm solving for y, so I'm going to move my 2x over, okay, which changes it to a negative and shift my 10 over. And then divide by 5, divide by 5, divide by 5. So y equals a negative 2/5 x, and then plus 2. Okay, so graphing that at a positive 2. Okay, and then from there I'm going to go down 2, so back down 2, and then over 5. 1, 2, 3, 4, 5. Okay, so we're graphing that one. Okay, this one's kind of written weird. To get the y by itself, I'm going to actually multiply by the fraction to get things flipped. Okay, so I want to get rid of this fraction. Okay, so I'm going to multiply by its reciprocal. Okay, so I'm going to put 2/5 here. Okay, so I'm just taking that because I want to get rid of the fraction, because I don't want a fraction in front of the y. It's okay to have a fraction in front of the x, right? But just not in front of the y. So we want to totally get rid of that fraction, not just the 2. Okay, we want to get rid of the 5 as well because we want to get y by itself. Okay, so when I distribute this to here, I would get, so I'm going to write this up above, 2/5 x. Okay, when I distribute this to here, the 5s would cross cancel, and it would just leave a positive 2. Okay. And then when I distribute here, the 5s cross cancel and the 2s cross cancel. So the only thing that I'm stuck with is the y is still going to be a negative. Okay, so then negative y. Okay, now I want to get y by itself. So I'm okay with it being on the right side, right? But I want to move this over to the other side. Okay, so I'm just writing mine backwards, which you can rewrite it if you want to. That it's y equals, and I'm just going to put an x plus b. Okay. All right, so my y, I'm leaving it alone for right now. I'm moving the 2 over. So the x is already where it needs to be. So I've got 2/5 x. Okay, I'm not moving that. I'm just moving the 2. When I move the 2 to the other side, it becomes a negative 2. Okay, now to get my y by itself, I need to get rid of that negative. So when I do that, it's going to switch everything to the opposite sign. Okay, so now I would have y equals a negative 2/5 x plus 2. Okay, so if I go to graph that, I'm graphing this part first, right? At a positive 2, so up 1, 2. Okay, and then from there, I'm going to go down 2, 1, 2, and then to the right 5, 1, 2, 3, 4, 5. So if you notice, these two lines wind up being on the same line. Okay, so both of the equations are on the same line. So I want you, when you do these, just so I know that you're recognizing that, is to actually write the same line, so when the person that's grading your paper knows that you graph both of those lines. Okay, if you don't write that, then we'll just assume that you only graph one. Okay, so what this means now is that we would call this dependent. Okay, and this is kind of leading into another section that we have coming up. So dependent means that you have many solutions. Okay. So before, don't write this, but before we had graphs, okay, if we had a line that went like this, okay, and a line that went like this would be the solution to your equation, is where those two lines cross at. Okay, okay, so whatever the coordinates for that, that would be one solution. So you would have an x and a y, okay? When they're parallel to each other, so say I have a line that goes like this and a parallel line that goes like that, it's no solution because they never cross each other, okay? But this one that we just did, they're both on the same line together, and lines go on forever, right? So this is why it says that there's many solutions, is because anything that falls on this line is going to be a solution to both of those equations, and it just keeps on going on forever. Yeah, that's fine. Okay. So same line, we call it dependent instead of independent. You'll learn about independent in the next section, but this has many solutions. Okay, so moving away to the graphing, and we're going to substitution and then to elimination. So substitution and elimination are just two different methods to get to the same answer. Okay, sometimes one is easier than the other, but both of them will get to the same way. So sometimes we learn one way and like one way, and you can do all of these problems that way. Okay, so substitution means you are going to plug something into the other equation. So anytime we're using substitution, generally there's a variable by itself. Okay, so what this says is y is 4x minus 6. So if y is that, then that means I can take this and plug it into the other equation where the y is at. Okay, so I'm going to rewrite this equation right here, and I've got x minus 4, and I'm replacing the y with what we just said it is, okay, which is 4x minus 6, okay, and then the rest of the equation equals a negative 6. So if you notice, now all we have is x's in that equation instead of x's and y's like we did in the previous one. Okay, so now we're solving for x because that's the only variable that's in this equation. So if I distribute, I would have x minus 16x plus 24 equals a negative 6. Okay, combine my like terms, so I'd subtract and get a negative 15x. Okay, I'm going to move this over to the other side to get the x's by itself, so that would change it to a negative 24, which means I have a negative 15x equals a negative 30. Okay, so divide by negative 15, divide by negative 15, so my x is equal to 2. Okay, so now we have one of our variables, we just don't have the other one. So now you just choose, and it doesn't matter because it has to work in both equations, so you can choose this one or this one to plug in for the x. So x is 2, okay? So if I wanted to plug it into this one right here, I'm replacing the x with a 2, because that's what x is, and now I can solve for y. Okay, so 4 times 2 would be 8, and 8 minus 6 would mean that my y is also 2. Okay, so I just said that you can plug it into either one of the equations. And so if you're checking your answers on tests, you can do it mentally in your mind, but I would plug it into both of them to make sure it works because it has to work in all the equations that they gave you. So if that's the case, I'm going to plug into this first one up here, okay, so this one right here. Okay, so x, you said x was 2, so I'm replacing the x, minus 4, and then my y was also 2. So what you're checking is to see if the left side of the equation equals the right side of the equation. Okay, so this is 2, this would be a negative 8, and yes, it equals a negative 6. So I know this is a solution to my equation for both of them. Okay, so you can write it like this. When you go to do the multiple choice, you'll notice they'll write them as coordinates. So the x is first and the y is second. Okay, this shouldn't be anything new. If you've done this, we reviewed this last year and you did this in algebra as well. Okay, but this is leading to a section where we're algebra 2 going to have multiple equations, not just 2 equations. Okay, so we've got to practice this. Okay, so same thing. I'm going to plug this in and replace it in for the y. Okay, so I have 3x plus 4. I'm replacing the y with what it says it is right here, which is 2x minus 5 equals 13. Okay, so I got it where all the x's are by themselves. There's no y's in this equation. I need to distribute. Okay, so I've got 3x plus 8x minus 5 equals 13. Okay, combine my two like terms. So I've got 11x move the 5 over, so it changes from a negative to a positive. Okay, and then, oh, wait, there, sorry, 4 times negative 5 would be 20. Why does this not look the same? So it's a negative 20, which changes it to a positive 20. Let me do that in every color. Okay, we're going to move this over. Okay, so now I have 11x equals 33. Okay, so divide by 11, divide by 11, so x would be equal to 3. Okay, so you can choose to plug it in for this equation or this equation. Does not matter because remember it works in both. I usually just pick the one that looks the easiest to me. Okay, so for me, this would be this one. Okay, so I'm going 2 times 3 minus 5. Well, 2 times 3 would be 6, and 6 minus 5 gives me 1, so my y is 1. Okay, so if I plug that in to check it with this one, 3 times 3, right, would be 9, and 4 times 1 would be 4. Well, is 9 plus 4, 13? Yes, so that means my answers are correct because it worked in both the equations. Okay, one more substitution. It's just a different variable this time, and then we're going to elimination. Okay, so instead of a y this time, we have an x. So I'm going to replace the x with that. So I'm going 3 times 1 minus 3y minus 2y equals a negative 19. Okay, so distributing. Okay, combining our two like terms. Okay, so I've got 3 minus 11y equals a negative 19. Subtract my 3 over, subtract my 3 over. So I've got a negative 11y equals a negative 22. Okay, divide negative 11 into there. So y would be 2. Okay, so this time we solve for y because if we started out with solving for x, we're plugging x, so we're going to get the y answer. So that means now I'm going to plug in y into one of my equations. And again, remember, it doesn't matter if you plug into this one and solve for x or plug into this one and solve for x. Again, I choose the second one just because to me it's easier. Okay, so I'm replacing y with what we just solved for, which was 2. Okay, so now I have 1 minus 6 for what my x is, which x would be negative 5. Okay, and again, you can plug that into the other equation and see that it equals a negative 19. Okay, so now we are going to solve by elimination. This one was substitution. This one is called elimination. So when we do elimination, you'll notice that there's no variable by itself. Okay, so what we're choosing, and it doesn't matter because you have to solve for both, is which one looks easier to get rid of. And when we get rid of it, we mean that the numbers are the same, okay, like the x's are the same or the y's are the same, and then one of them is a positive and the other one is a negative. There's no right or wrong way to start this. You can just choose which one looks the easiest for you. Okay, so to me, when I look at these, I picked this one just because there's already a positive and a negative, where the x's did not have a positive and a negative. So I just chose this one. Okay, so this one has a negative 4, this one doesn't. So I need it to be a positive 4. In order to do that, you can't just put a plus 4 there. You have to multiply the whole equation by whatever you're changing it by. Okay, so that means this one I need to rewrite. Okay, so I am going to multiply this by 4. Okay, so when I distribute this, I'm going to get 8x. Okay, distribute. Oh, pretend like I got 4 in there. Which would be plus 4y. Okay, and then 4 to negative 4 would be a negative 16. Okay, I'm just going to move this guy over here. Okay, so I've got 4x minus 4y equals 22. Okay, so if you notice, our whole goal was to eliminate something, and we just eliminated the y's because we have a positive 4 and a negative 4. Okay, so now you just combine what is left. So 8 plus 4, this is a positive 4, is going to give you 12x. Okay? I have a negative 16 and a positive 22, so subtracting the 2 would give me 6. Okay, so now to solve for x, I would divide by 12, divide by 12, so my x is equal to 1/2. Okay, or you can plug it back in as 0.5 as well, right? Because that's a terminating decimal, so either one, which sometimes I think plugging into your calculator is probably easier to plug in the 0.5. Okay, so I'm choosing to plug into this one in here. Okay, so my x is 0.5. So if I go 4 times 1/2, okay, taking half of 4, right, minus 4y equals 22. Okay, well, 4 times 1/2 or 4 times 0.5 would give you 2. Okay, so I'm going to subtract my 2, subtract my 2. It's me 20. Okay, and then get my y by itself, so I divide by -4. So that means my y is a -5. Okay, so again, just like the substitution ones, you can plug this back in, like to that top equation, to see if it works. So if I went, and I know I just did this thing, this guy was 2x plus y equals. Okay, so if I plugged in 0.5 in for my x, taking half of 2 would be 1, right? And then I would have a -5 for my y. So my left side equals my right side, so that I know that I did it right. Okay. Number 12 is our next one. And then I'm going to have you try that last one on your own to check it. Okay, so elimination. So again, looking at x's or looking at y's, this one, neither one of them has a positive, negative, so it does not matter. If you chose to get rid of the x's, then you're just thinking of what can both of those numbers go into, okay? And the same thing for the y's, okay? I want to work with the y's, is what I'm choosing, okay? So 4 and 3, okay, those two, 4 and 3, can both go into 12. But I need them both to be 12, and I need one of them to be a negative. Okay, so to make this 12, I would need to multiply it by 4. But remember, you got to multiply the whole equation by 4. Okay, to make this 12, I would need to multiply by 3. But remember, I need one of them to be a negative, so I'm just going to make the second one my negative. It doesn't matter. You could have done the top one if you wanted to. Okay, so now we're distributing. So I'm going to distribute the 4 through. So 4 times 6x is 24x. 4 times 3y gives me 12y. Remember, I was trying to get 12. Okay, and then 4 times 1 would give me 4. Okay, now I need to distribute this. Okay, going through. Just don't forget that last one. For some reason, distributing to that very last one, people forget. Okay, so this would give me a negative 12x, a negative 12y equals 6. Okay, so looking at my equation, my y's went away because that's the whole idea behind eliminating. Okay, so this gives me 12x, and then 6 and 4 give me 10. Okay, so I'm going to divide by 12, divide by 12, reduce these. Sorry, guys. Reduce these when you can, okay? So obviously the 12 go away. I'm not going to mark through it because I did, but this and this can be reduced. Okay, so if I divide by 2 here, that would give me 5, right? Divide by 2 here gives me 6. It's easier to work with smaller numbers, okay? So this is my x. Okay, so now I'm choosing to plug in my x. I'm going to choose to plug it into the first equation. So where the x is at, I'm going to plug in my 6. You'll see why. And then put it in there, okay? Versus plugging it into the 4, and the 6 doesn't go in the 4, so it's just easier to do that. Okay, and then plus 3y equals 1. Okay, my 6's would cross cancel, which just leaves 5. Plus 3y equals 1. Okay, I'm going to subtract my 5 over, so now I have 3y equals a negative 4. Okay, and then just divide by 3. Okay, so now my y is a negative, whatever it is. And just leave them improper, okay? Because this would be a repeating decimal, and you don't want to have decimals, okay? And we don't want to have to plug back in mixed fractions. So we want to leave them improper because it's easier to cross cancel when you have these, okay? So there's your x and your y. Okay, so this one, I really, really encourage you to see what you can remember on doing this. So just as a hint, I'm telling you that we need to get rid of the fractions, so we multiply by the common denominator, right? You do that to the top one, and then you do the bottom one separately, and then go from there and do what we did. So I'm going to pause this video, and you're going to try it. Okay, going through this so you can check your answer. So the common denominator for the top one was 6. Okay, it was 3, 2, equal to 6. So when I put 6 on the outside and distribute it, and I'm starting on the right side, this 3 goes into that 6 2 times. So it's really 2 that I'm distributing here. Okay, 2 goes into 6 3 times. So it's really 3 that I'm distributing to whatever's left with the numerator. And then again, 3 goes into 6 2 times, so 2 is distributed into that there. Okay, so my equation is written off to the right. Okay, 15 is common denominator for this because all of these can go into 15. Okay, so 15 goes into 15 one time. So 1 times 14 is going to be 14. 3 goes into 15 5 times. So 5 gets distributed to there. So that gives you negative 5y. And then 5 goes into 15 3 times. So 3 gets distributed to there. So 3 times 2x is 6x. Okay, so now you got to look at what you want to get rid of, what's easiest for you. You could have done the y's and made them both go into 15 and multiply the top one by 5 and the bottom one by 3. To me, it's easier to get rid of the 6's because I only have to change one of the equations. Okay, this 6, I can make this one into 6 by multiplying it by 3. Okay, but remember, I need one of them to be a negative, so I'm going to make this one the negative. Okay, so I'm distributing this to each one of these, okay, so that I can combine them with that bottom equation. Okay, so now I have a negative 6x plus 9y equals negative 30. Okay, these guys go away. This would give me 4y, okay, and that gives me a negative 16. Divide by 4, divide by 4, so my y is a negative 4. Okay, now, I would not choose to plug it back into these guys that have the fractions, okay? I would go back and plug it into one of the equations that you rewrote them, because they are the same equations. We just made them bigger and got rid of the fractions, so they're the same thing. So to me, this one's the smaller number, so I'm going to choose that one to plug in, okay? So I have 2x minus 3, and I'm going to plug in for my y, which was a negative 4, equals 10, okay? So combining these two, so now I have 2x plus 12 equals 10. Subtract my 12, subtract my 12. So now I have 2x equals a negative 2. So then that means my x is equal to negative 1. Okay, so I have my two answers. So a negative 1 for the x and a negative 4 for the y. Okay. So what you guys are doing when you're done with those notes is to get onto the calendar, and you're going to open the attachment for the triads, okay? And then you will be handing this in tomorrow after the test. So make sure that you are ready for the test for objectives 40 through 44.